Suppose you need to pull your broken car with a rope. What moving angle should you choose? A large angle relative to the ground, or a small angle close to parallel with the ground? In the first case, the force vector is making a large angle relative to the car's displacement vector. In the second case, the force vector is making a smaller angle relative to the car's displacement vector. The work done on an object equals the scalar product between the force vector and the displacement vector. Hence, the magnitude of the work done depends on the angle between the two vectors. The value of the cosine of theta is maximum when the angle theta is 0. As the angle changes from 0 to 90 degrees, the value of cosine theta decreases until it becomes 0 when theta is equal to 90. So, for the dot product to be maximum, the angle between the force and displacement vectors must be 0. Therefore, by the scalar product, you can get more work done by pulling the car at an angle as close as possible to 0 relative to the car's displacement. This work done by your pulling force equals the change in kinetic energy of the car. Now consider the case where two people work together on a moving car. The person at the back of the car pushes horizontally with a force of 30 newtons. The person at the front of the car pulls with a force of 13 newtons at an angle of 30 degrees with the displacement of the car. What is the net work done on the car as it moves 20 meters to the right? The net work done on an object is equal to the scalar product of the net force and the displacement vector. First, calculate the net force by adding the vertical and horizontal components of the forces applied on the car. Then, make a table of known and unknown variables and replace the values in the formula. Now calculate the scalar product between the net force and the displacement vector. Work is positive as work is done on the car by the two external forces, so the car's kinetic energy increases.